Is now starting. All attendees are in listen-only mode.
Hello, my name is Drew Sukup. On behalf of VMUG, I'd like to welcome you to today's Dell Technologies and NVIDIA webcast, How to Optimize Your Remote Work Setup, presented by Manvender Rawat, Product Manager at NVIDIA, Ben Murphy, Senior Director of Product Management at Lakeside Software, and John Kelly, Product Manager for Virtual Desktop Solutions at Dell Technologies. Thank you for participating in today's webcast and for your continued support in the Global VMUG program. Before we begin, I have 3 quick housekeeping items to go over. First, today's webcast will be recorded and available for you on demand. You will receive an email with the on-demand link, so keep an eye out for that. Second, a Q&A session will follow today's presentation. All questions will need to be entered in the question window near the bottom of your GoToWebinar screen. Third, there will be a short online evaluation that pops up as you exit the webcast. Please take a minute and let us know what you thought of today's session and what you might like to see going forward. All attendees from today's webcast who opted in at registration will be entered into a raffle to win one of 4 $25 Amazon gift cards. The winners will be contacted directly by NVIDIA, so good luck. All right, let's get started. Ben, I'll turn it over to you now.
All right, that's perfect. Thanks a lot. And thanks everyone for your time and attention. Today, we're going to be discussing how it is that you have the ability to make a remote workforce a more optimal solution for either end users in your environment or for people that you provide services to or whatever it is that you're looking to accomplish. But the core of what we'll be presenting today focuses on the idea that user experience is largely predicated on the ability for a device and for applications to support the needs of what it is that end users find themselves doing on a day-to-day basis. Well, there are a lot of things that obviously have a direct impact on the expectations of the end users that you service. And of course, the circumstances of everyone's work life has changed significantly under the circumstances of course, the global situations that we're dealing with. But the net is many things are a consistent and understandable trend, even in the midst of some uncertainty. So one thing that we'll talk about is that across the board, graphics demand is becoming a increasingly non-optional part of what it is that people need to be productive. That in and of itself is a change from how things once were, in that many of the core applications that you interact with on a day-to-day basis actually have graphics acceleration as part of how that app is supposed to function. And we'll talk about what that means. We'll talk about what the expectation for graphics acceleration means in terms of performance on an endpoint. The other things that we'll talk about, though, that directly relate to that is an existing expectation for things like business continuity, the ability for users to get access to remote systems securely, efficiently, and with that, still enjoy the same quality of experience that they can get on a device that might have a more fully fledged, shall we say, experience on it. So, for example, if I'm remotely accessing a remote session, let's say on a mobile device or an iPad or something like that, I anticipate that pretty much ubiquitously, so if I'm at a coffee shop or if I'm at home, I should get some kind of comparable user experience out of that. Well, the question is, of course, how is that something that you can accomplish, and what are some areas that we can explore that might make it more clear cut how you can do that in a simple and straightforward way? So those are some of the things that we'll explore. Obviously, there are some complexities that apply to every environment, but across the board, there are some pretty important things to keep in mind as context as we work through this. So one of the items that is, I think, non-controversial is that productivity, meaning what it is that you have end users actually doing on a day-to-day basis to be productive for the business, is largely dependent on, are you capable of doing your job with what you have been given? So that means that user experience, in large part, is a very important part of the DNA for most people of success. And because now we have a large number of users who either are working remote full time or a portion of the time, that means that you have to make sure that you've got some consistency in that user experience, no matter how it is that people are working. Now, for many people, virtualization is an answer that works exceptionally well for how do I give someone a consistent look and feel, a consistent set of applications, and a secure method that allows me to control what is, let's say, egressed or ingressed into a particular environment, or whatever your need might be. Now, for our purposes, we're going to focus a little bit on virtualization because it has a very interesting history in terms of graphics, but we'll kind of get there when we get there. For the moment, though, the important thing that we want to highlight is that virtualization is in and of itself an interesting case study in understanding where it is that user experience problems can come from. So, as a bit of background, and this is data that is, even independent of data that Lakeside has collected, and we'll talk about what that is here in a second. Most environments at this point have kind of dabbled with VDI. Now, there are many issues that you could run into depending on what it is that you've chosen to deploy, or how thorough that kind of investigation has been. But there are really key pieces of making sure that when you do deploy a new environment, it works well for users. So let's cover off the state of play right now. So obviously we've got a lot of other folks out there in the industry that also do surveying and kind of a state of the union, if you will, of the state of play for virtualization. So I'm sure everyone's familiar with the end user computing state of the union VDI work. Their data, of course, indicates that we've got a large number of people that are very interested, but do have some issues delivering a good quality of experience. So the issues there can, in general, either be client related. You can have networking or intermediary issues that sit between that client and whatever remote session you've got. And then you've got the remote session itself. So unfortunately, in a lot of cases, high latency is not an imminently solvable problem, because you may or may not be dealing with an ISP or any networking route that is directly under the control of the organization. So for our purposes now, I'm not going to say forget about it, but we'll focus on some other areas, namely the ability to deliver a good, high quality performance for things that people expect to use, namely 2D, 3D interactive elements that drive graphical components. In our experience, a large component of why some people may not enjoy the experience that they get is because there's an expectation of no stuttering. You have an expectation of your common productivity applications being able to open and do what you want. And sometimes that can be a missing element of that experience. So we'll talk a little bit about how we collect data and what user experience means to us. But the net is, we, as an organization, collect normalized and anonymized aggregate data about our customers. So Lakeside Software is and has been a digital experience monitoring tool set that allows you to collect meaningful information about your environment, and then to compare that data to peer groups or across large segments of a given population. So throughout our presentation, we will be highlighting some of those elements, namely what have we collected from our millions of devices under collection, and what can we take away from that in terms of findings that support some of our thoughts on how to make an environment better. So in this case, we actually have a lot of data that indicates some really key things that set up why would I say that graphics is a really important part of someone's VDI experience. This is what we'll spend some time going through, and then I'll pass it over to NVIDIA to go through some of the different configuration items and exploration of data specifically with vGPU. So Monty will walk through that. And of course, later we'll also introduce Dell Technologies and John to go through some of their own experience with that as well. But for now, we'll start with the predicate of this is anonymized data that comes from a very large and representative sample of different device types and different types of industries and different scales. So I'll point out some things that are of note as we look at the data, but the key is this supports some of the conclusions that we'll draw in the course of our presentation. Now, the key for me is even if you just look at a very basic piece of information, the state of play has changed significantly over time. Now, when we say average weekly graphics per user, what we mean in this case is we are looking at active consumption of GPU runtimes as a part of the normal operation of an application. Might sound like an abstract idea, but the basic concept is we are looking at the amount of active interaction that users have with apps that are driving GPU consumption. So in this case, what we're doing then is using that data to say something pretty simple, which is over time, the trajectory of that graphics usage has increased significantly. So if you look at the rate of change, it's pretty significant in that now most of what people do throughout a week, so your average user is in the ballpark of about 40-45 hours per week of like real usage. Most of that does involve some form of interaction with a graphical requirement of some kind. Now, obviously, we'll get into some details about what does that really mean, but it does tell us that in general, even the common productivity apps that for a task user, for example, you might not expect to drive graphics demand will do so. And they will happily take a lot of compute resource usage a lot of times in order to render whatever it is that you're looking to do. Obviously, there's a lot of caveats and the specifics may vary, but a lot of the aggregate data tells us a very consistent story about that. So basically, it is an expectation at this point that you're going to have some form of graphical demand in pretty much any workload. Now, when I talk about productivity apps in this case, I am strictly speaking now talking about the small suite of apps that constitute things like your Office suites and even some of the browser-based interaction with those. So even some of the newer suites that have started to add in workflow to their kind of general app, and we'll take a look at, let's say, like a Dropbox and Paper, for example, meaning their interactive / collaboration platform, that in and of itself drives some graphics usage. In fact, it is so high at this point that ubiquitously across pretty much every version of Office that most people will be using, you're going to have graphical demand as part of that workload. So this is more to the point that it really does not matter what workload we're talking about. It is going to benefit from graphics acceleration. Well, that becomes important when you start talking about seriously impactful situations like, let's say, VDI, because it can have a huge impact on your density and the quality of experience that people get therefrom. So as an example, if we look at some case in point kind of productivity app data, this tells us some pretty interesting stuff, and it is in support of what we mentioned before, that in general, our compute resource usage is increasing at points where people are active. So to simplify what can get into a bit of a statistical thing, the idea here is as you see the years increase for each of these product sets, you see a relative increase in CPU usage. And this indicates, and again, we have some more granular data for this as well, that we're seeing an increase in resources dedicated to the rendering and kind of graphical consumption for the app. So you see a decrease in this if you have some kind of graphical acceleration. Well, this is important because once you start to see some of these really big spikes, especially with the later, more as a service delivered versions of your Office products, a lot of times some of the direct control leaves your hands as to when it might choose to do something like implement some new graphical element that might add some workload to this. So to mitigate the risk, this is where graphics usage indicates you need something to support that demand. So that graphical usage, the robust or rich content that people consume, requires something in order to make sure that you're delivering a consistent user experience. vGPU is a very good example of that from NVIDIA because it provides you with an ability to not only offload some of that compute resource, which gets you potentially increased density, but really importantly, and this is the thing that I will stress across the board, a better experience. And the business has to decide which one of those two things is more important. I think that productivity and user experience go hand in hand, and to me are very important. But again, all of this information that we're looking at here is in support of a pretty simple thesis, which is the graphics demand for users has across the board increased, and you need to accommodate that. Another thing that we've noted, of course, under the circumstances, monumental increases in the demand for video conferencing or just general remote meeting services. I will say that's a pretty obvious statement, but again, that is not probably going to change. And because of the nature of these apps, you also know that in general, you're going to want to have some form of either graphics processing or a form of a method that can offload some of that graphics demand. So again, everything that we're walking through here is basically in support of the fact that performance at the VDI layer can be greatly helped by the implementation of some form of graphical support for that workload. So with that, you've probably heard about enough from me, so I'm going to hand it over to Mani from NVIDIA, who will walk us through a little bit of their information on vGPUs.
Thank you, Ben. That was very insightful. Hi, everyone. So as Ben mentioned, the graphics requirements for the data center is growing with each year. And most of the apps that are developed in this era are developed with graphics acceleration in mind, right? So any device that you would have from your iPhone to your tablets, they all have some sort of GPU acceleration baked in. Right, but when the same thing translates to a data center and specifically to a VDI infrastructure, that functionality is lacking without a solution that allows you to share the GPUs in a time slice fashion. How do I look to the next slide? So yeah, virtual GPUs provide you that functionality, which allows you to basically deliver rich graphics content for all sort of workloads that can be accelerated on a data center. So on the left-hand side of this diagram, you're looking at a typical VDI deployment, right? You've got a server, hypervisor, and then a bunch of VMs with applications and running on top. For virtual GPU to complement that deployment, if you install a NVIDIA virtualization software or vGPU manager at the hypervisor and have NVIDIA's data center cards present at the server, you get different functionality and different products that can accelerate different sort of workloads. If you look at the NVIDIA vGPU product family, you can see that we have products kind of catered towards different industries and verticals. Today, we're going to talk mainly about the NVIDIA Grid Virtual PC and application product line, which is kind of targeted towards office productivity and knowledge worker workloads. We also have a Quadro Virtual Data Center Workstation product, which is mainly focused towards the heavy performance and heavy VDI, heavy professional visualization family, and the NVIDIA Virtual Compute Server, which is targeted towards AI, deep learning, and data science. As Ben already covered, video conferencing trends have risen, and we've seen a great uptick in the amount of downloads and amount of usage we are seeing for various video conferencing applications. And obviously, the pandemic has accelerated, the work from home, and everyone is kind of dependent on these video conferencing apps for business continuity these days. So for this exercise, what we did to back up what Ben just covered through the Lakeside and normalized data, we actually ran a series of tests with various video conferencing solutions, and one of our internal benchmarking tools for scalability testing on VDI environments called nVector to kind of second bend data. So if you look at the video conferencing test that we did, we ran tests using Dell servers with Xeon Skylake CPUs on Windows 10 Enterprise 1909. For the VMs, we configured 2 vCPUs and 4 GB of RAM. And the tests were basically a comparison between a VPC-enabled setup versus a CPU-only environment. So for the VPC-enabled setup, we had a 1 gig profile configured that would allow each of the VMs to have access to the GPU and a dedicated 1 gigabyte of frame buffer. For the test, we actually ran 2 different tests. One was for just the webcam activations. So there were 3 participants who were logging incrementally and kind of logging out at the same time after the interval. This kind of shows the impact of adding video streams to your existing WebEx. And the other most common application that we've seen is the screen share. So the second workflow was participant and host are sharing the screen, and how does that impact the usage and overall resource utilization. For this test, we targeted 3 of the most popular apps. So Zoom, Microsoft Teams, and Cisco WebEx were the ones that were tested. And to remove most of the variables that can impact the performance, this was done, the testing was done in a lab environment. The configuration between the 2 CPU and the non-GPU setups are exactly the same. So there's very little variability between the tests, apart from the fact that one of the setups has a GPU. The monitor and resolution and software configuration, everything else remains exactly the same. Now, if you look at the results, so in general, the results were consistent across all the different video conferencing solutions. And what we saw was that there is always a spike of almost 100% on a CPU-only VDI. And especially when we're activating these cameras and when new people are joining this meetings, there is always a great spike that can very significantly impact your video quality and result in pixel loss and stutter. We also observed audio delays and breakages, which kind of rendered the whole conference unusable, because you can't listen to the participants, then there's no point. And when we tested the same thing on the NVIDIA Grid VPC solution, we didn't really see all the spikes, and everything was offloaded to the GPUs, which resulted in a very enhanced user experience. And because of the lower CPU utilization, there was a potential of adding additional users to the same server. For the screen sharing test, we also observed that we were delivering higher frames with the GPU present in the system, which is kind of expected. But obviously, it results in a better user experience and a more snappier performance for all the participants. Now, looking at the results more closely, if you look at the graph, the blue line kind of highlights the CPU-only VM, and the various spikes that you see in there are when the webcams were getting activated. There are only 2 vCPUs in these VMs, so you can see that it kind of bottles, it kind of caps at 100% for most of the testing duration. And this problem can be resolved if you add 2 more CPUs to that VM and increase the total vCPU count to 4. But that would greatly hamper your overall scale on that server, right? On the other hand, if you look at the VPC-enabled VM, you can see that it's consistently at 30% of the CPU utilization for the entire duration of the test, and there are very little spikes during webcams and other processes being added to the testing duration. So, I mean, this kind of goes on to show that for if you even just consider the resource utilization, you can see there is a great benefit of offloading the task to from the CPU to the GPU, which kind of increases your scale and provides you much better user experience. Now, for Microsoft Teams, what we did was we ran the screen sharing test. So, the presenter is sharing a screen. And what we observed was that the amount of frames that we deliver is much higher on the VPC-enabled VM. Now, again, this is kind of expected because you've got a GPU present in the system that can churn on more frames. But at the end, it results in much higher smooth user experience for the end users, which which is obviously very desirable for these kind of scenarios. Now, to be fair, we basically ran one more test for using these plugins that can do media redirections, and we saw that if you have a powerful enough client, you can redirect quite a few, most of your GPU tasks to your end client. But there is a big caveat there that the IT admins would have to kind of support a wide variety of clients and kind of certify different stacks, which might create different problems. So we move on to the second series of our testing that is kind of based on NVIDIA's internal benchmarking tool for VDI, which was written internally by our team maybe 3 or 4 years ago to quantify the benefits of GPU acceleration, especially for VDI and scaled environments. As part of the Invector workload, what we did was we created a framework that lets you orchestrate your tests, provision the VMs. We wrote our own workload, which is kind of representative of what a real knowledge worker would be doing on a day-to-day basis. So we use a bunch of office productivity applications, used PDF browsing, scrolling, and the operations which are very typical to a modern-day user. Added something like a YouTube browsing, PDFs, Chrome, and other workloads which are very representative of what I and others would do on a day-to-day basis. And at the end, we kind of created a series of metrics that we collect and use to judge user experience. So in short, we have 3 important metrics that we collect and use to quantify user experience. So the first one is the end user latency, which is essentially encompassing everything from your network latency to your hardware and software latency during the execution of every operations in VDI. So what we essentially do is we capture a keyboard click on a virtual client and send it across the wire to the data center. And based on the click, basically we make a change on the screen, a pixel change on the screen that is monitored at the end client. Now this overall flow gives us the entire round trip latency from the click to the packet being sent over the wire to it being encoded and decoded at the server side and then sent back to through the same channel. Now this is very useful in identifying how responsive your screen is, how much time does it take for a click to actually turn into action, and this kind of gives us quantify the responsiveness of the session. We also measure frame rate, but the frame rates that we measure are at the end client, and we measure the image quality by collecting image samples both at the server side and the client side, and then doing structural similarity comparison between them. Now these all 3 measurements, as you can see, are done at the end client side and not the server side, right? Because the servers can keep on getting more and more powerful, but the user experience is something that should be measured where the end user is actually placed. So which is at the end client side. Now, apart from the user experience measurement, we do measure resource utilization, and resource utilization and user experience measurement together helps quantify how well your system is architected, right? Is the user getting a good user experience while they're constrained on the resources, or vice versa? Now, looking at some of the results that we collected from running mVector in scale. So we have normalized those results, and on the left, you can see the graph for 32 vCPU VMs, which is getting end user latency score of 1. Now, end user latency is the lower the end user latency, the better, right? So you can see that if you compare that to what we got for the VPC VM with 32 VMs running, it's actually 40% lower than the same score for CPU only VM. And another point to highlight was that even if you scale or double the number of VMs on that same server to 64, your end user latency remains constant, which means that increasing number of VMs doesn't really impact how each user is perceiving or how much responsive its setup is. Now, this is obviously a result of everything, or quite a few operations being offloaded to the GPU, right? And we can on the right hand side, you can also see similar things for frames. Now, what we can see is that we're basically delivering 33% more frames for the VPC enabled VMs, and that is also consistent across scale. So even if you're going from 32 to 64, it kind of remains constant. Now, moving on to multi-monitor setups, right? So the previous test that we saw was essentially for a single monitor full HD configuration. Moving on to a dual monitor setup, what we want to highlight is that you can see that obviously the GPUs are time sliced, but the frame buffer that we allocate for each VM is dedicated to that VM, right? And adding more applications or resources or increasing the resolution, number of monitors would actually occupy more space on that same allocated frame buffer, right? Because finally the display is being drawn in that GPU memory. So what we see here is that during the execution of the test, for the light green line, you can see that for a single HD monitor with a T4 1 gig profile, you can see that the GPU usage of the frame buffer starts at around 45% and creeps up to like 60%, which is like a sweet spot. But while you're running dual HD configuration on the same VM, the GPU frame buffer utilization is higher, and it's kind of creeping up to 90%. Now, this is all good. I mean, I think we can easily put 2 HD for this kind of workload in the VM that we've configured right now. But as you can see, if you want to add one more display, probably that you'll have to probably bump up the profile and get a 2 gig profile. So my basic recommendation would be run your POC based on the workload that you're targeting, right? Because we do have support for up to 4 HD monitors, but depending on the workload, you might be able to get 2 or 3 displays in there. Now, looking at single 4K monitor results, since we already know that it's taxing on the frame buffer, we started off running with a 2B profile, and you can see that it's the VM frame buffer utilization is pretty average, right? So it's really in the sweet spot. So if you're running a 4K monitor, you would recommend going with a 2B profile. Now, we've done some extensive testing in our performance lab, and here are our typical recommendations for multi-monitor setups that are deployed with VPC. We will be sharing the slides later on, so you can take a look. But in general, the recommendation remains the same. Run your POC and size your setup for basically your workload. And so there are ways to try out VGP software. So if you have an existing setup, you can basically get the 90-day evaluation license from our website. If you would like to just take a look at a setup running on a cloud environment, we have a VMware test drive that lets you enroll and then allocates Horizon VM for a few hours. That lets you try it out. And with that, I think I'll hand over the control to John.
Hey, thanks very much, Manny. It was great hearing from Manny and Ben about the importance of end user experience for VDI, how NVIDIA can obviously improve it, and Lakeside can help you to monitor and assure it. And of course, at its core, a VDI environment really needs an infrastructure stack, and that's why it's great, and I'm really super excited to get the opportunity for a few minutes here to discuss the Dell Technologies infrastructure stacks that work well for VDI, and also talk briefly and in terms of comparison about on-prem and hybrid cloud VDI, and compare those to hyperscaler DAS solutions, because they're obviously in the current global environment and in the context of the pandemic, etc. There's options that a lot of companies are looking at for remote working. So wanted to take a look at those. So if we take a look at the slide that we're sharing right now, obviously VDI, the first thing to point to make is that VDI is an end-to-end stack. It requires the right pieces and parts at each layer in order to provide that good end user experience, which we've been discussing has been so important. And Dell Technologies does provide each of those parts, from the client, which is typically a 10 client, but can obviously also be another piece of our client portfolio. Then the next layer or piece of the solution stack is the virtualization software layer. So you've got the hypervisor, and the infrastructure management and monitoring pieces, and also as is most relevant to today's conversation, the VDI management piece, obviously with a broker such as VMware Horizon at its core. And that would be then obviously that environment, that Horizon-based environment, will run on the ESXi hypervisor. And then finally, the bottom row, if you like, of the slide I'm showing now is the infrastructure stack. So customers, in terms of the infrastructure stack, they can have multiple preferences depending on where they are in terms of a number of different decision criteria. They may have a preference for a particular data center form factor, for example. So it could be a modular solution, based on something that Dell EMC MX7000, or a rack mountable solution based on one of our Intel or AMD powered R740 or equivalent platform. They could another decision vector would be whether it's converged or hyper converged or classic 3-tier. And in those scenarios, be likely to select VxBlock, converged, VxRail, hyper converged, or PowerEdge from a classic server platform. Another decision criterion that's important is the build to buy continuum. You know, whether customers prefer to buy a HCI appliance like such as VxRail with fast time to value in the customer environment, or whether they want to run another vSAN based solution based on something like vSAN Ready Node, and in that case use their own management and LCM tool set. And you know, then finally a decision point that's really becoming you know, more widely discussed, and that our customers are you know, more frequently coming to us with, is in terms of the cloud journey, you know, and where customers are on their cloud journey for their infrastructure stack, including obviously, you know, what they run their VDI environment, and that's where, you know, Dell Technologies Cloud, which incorporates VMware Cloud Foundation, works well for customers who want a strong multi-cloud and hybrid cloud story. You know, and again, VxRail, product like VxRail works very well there, due to, you know, we've got strong integration between VxRail Manager on the infrastructure stack, you know, management and lifecycle management side, and VMware, you know, SDDC Manager on the VCF side as you move up through the stack. So you know, again, what we're seeing is that, you know, customers are at different places in their you know, journey to cloud, in terms of you know, data center form factor, build to buy, etc., etc. So, you know, there's no one size fits all, but, you know, I've outlined here some of the different solutions that can fit you know, each of the different as I said, points along the customer journey. You know, so one of the obviously one of the key discussion points here today is around end user experience, and therefore I did want to discuss on this slide one of the key changes that we see people making to improve their end user experience, and that's around repatriation, public cloud to hybrid or on-prem repatriation. And you know, at the start of the pandemic, you know, which seems like a long time ago now, back in the spring, you know, many customers we saw in an eagerness to get their remote working capabilities ramped up quickly, move to hyperscaler DAS environments, you know, built on things like AWS workspaces or Microsoft Azure WVD, Windows Virtual Desktop. But, you know, now for multiple reasons, really, they're reconsidering that decision. Things like price, data sovereignty, data locality between the desktop and the apps that they're using. You know, they're some of the factors that are causing the decision to be reconsidered. But, you know, when they think about you know, things like repatriation and which is the obvious consequence of, you know, re-examining those public cloud and desktop as a service decisions, one of the you know, the key barriers we've seen is that the architecture for things like AWS workspaces, Azure WVD, as I said, it can be quite different from a classic enterprise VDI environment. So really, it can be tricky to understand how to deal with topics such as, you know, classic enterprise IT pillars around authentication and authorization, user settings migration, and even, you know, the virtual desktop sizing, you know, mapping specific virtual desktop configurations in the hyperscaler DAS environment, mapping that to you know, a particular desktop configuration and density in the on-prem environment. So in Dell Technologies, you know, recognizing that and in conversation, you know, based on the conversations we've had with our customers, we've recently released a best practices guide to help our customers to repatriate from one of those hyperscale DAS environments to a Dell Technologies VMware Horizon-based VDI environment. And obviously as a Horizon-based environment built on things like Dell Technologies Cloud, that will support both on-prem but also hybrid cloud. And again, just to when I mentioned the cloud journey, this is I mentioned VxRail and Dell Technologies Cloud, but a lot of the guidance that we provide here is also relevant for other environments such as VxBlock and 3-tier PowerEdge based environments. So we've created that best practices guide. It's really jam-packed with information for customers who want to understand how to make that move from because of any of the reasons that I mentioned in terms of repatriation. So I'd encourage everybody to do a web search for cloud repatriation, Dell Technologies VDI, and download the best practices guide. It's free of charge. There's no there's no registration required, anything like that. It's on our Dell Technologies VDI Info Hub. Take a look at that. It does contain a lot of best practices, which may help you prove very helpful if you're looking at a repatriation initiative. And before I hand it back to Manny, I did want to talk about something called Ready Solutions for VDI. And what this is it's Dell Technologies guidance for VDI environment design. And all of this collateral that is available at the Dell Technologies VDI Info Hub that I mentioned a moment ago. And then at that Info Hub, we provide you with sizing guidance, design best practices, and obviously a key part of those Ready Solutions is post-purchase, the streamlined support and integration between our Dell Technologies support and VMware support organizations. Netting that all out and combining it, we really do see that it provides accelerated deployment, and help with guaranteeing a good initial end user experience, to avoid the dreaded, failed VDI pilot, which really is what damages many VDI implementations and causes them to stall before a full production implementation. So yeah, that's about it for me. Again, great to have the time here and to share the platform with Ben and Manny, and I'm happy to hand back to Manny now to I think he's going to share some information on NVIDIA resources, etc. So it's all yours, Manny.
Thanks, John. Right. So just to summarize what we heard today, we looked at Lakeside data that kind of points to graphics resources getting more and more prominent for VDI environments. User experience being the key that decides if users will stick to VDI or not. And obviously vGPU and Dell Ready Solutions with vGPU can help provide better user experience and CPU offload capabilities to potentially improve your scale on those servers. It will provide better user experience by improving your end user latency and delivering much better frames. And the recommendation from NVIDIA would be to run a POC and try out vGPU either by getting the trial software or trying it out on a test drive to experience it for yourself. The following slides actually contain a few additional resources. There are a lot of documentation on vGPU that you can look at, which might be very helpful. And with that, I would open it up for Q&A.
It looks like a lot of questions have already been answered by some of our organizers. And make sure to keep the questions coming in if anyone else has any, but if any of you three would like to answer this question, what's the model and maximum number of NVIDIA GPU adapter can be installed on a PowerEdge M640 server? We are planning to run VDI for GIS app on it and need high performance GPU.
The M640, what was this? Sorry, can you give the first part of the question again, please?
Yeah, sure. What's the model and maximum number of NVIDIA GPU adapter can be installed on a PowerEdge M640 server?
Yeah, let me take a look at that. I don't have that, obviously the M640. Let me take a quick look at that. There's a little more complexity on that because it's a modular based solution. So let me take a quick look at that, and I'll get back to you in a moment.
We have another question coming in. Is this compatible with Cisco Blade servers?
I guess that's a question for NVIDIA, right?
Right. So we have a product tailored towards Blade servers. It's still an older Maxwell series. So there's an M6 card that is tailor-made, and it works with Cisco Blade servers.
Great. And while we wait for
Drew, there's one question on there about whether a download will be made available of the slide deck. I think we had one that was being made available in the handouts. Is that right?
Yes, unfortunately, we had already started the webcast when I received that information, but a recording of this webcast will be sent out to everybody if they would like to view it again, and it's also available on vmug.com's webcast page. And it looks like we have another question here. We're using RDP in a virtual terminal server for some remote access clients. Would we see the same type benefit as VDI if we were to add an NVIDIA GPU to our host server running the virtual terminal server?
Right. So terminal service works in a different way to VDI. So there is a different NVIDIA product catered towards RDSH environments called Grid vApps. Now the difference between VPC and vApps is essentially that for VPC we would be drawing the entire display in the GPU frame buffer, right? So you would get the entire GPU, all the apps are basically rendered on the GPU itself. Now, when we talk about RDS and terminal service, what we end up doing is since the terminal service controls the creation of the displays, and that is done in the main memory. What actually ends up happening is all the instructions that are OpenGL or DirectX extruded gets passed on to the GPU and gets served. So in short, the experience might not be the same, but that's more of a technology limitation rather than a product limitation. But there would definitely be a better experience than not having a GPU, but it might not be same as a VDI environment with the GPU.
Great, and we have another question. The page with the links was only shown briefly. Can you place that slide back on the screen? It looks like, is that, yeah, there it is, perfect. All right.
Yeah, this is just, so the M640 isn't a product we've done a whole lot, so I'd need to. It's not immediately clear the NVIDIA card support for that. So, do we have a facility to include the answer in the Q&A and send it back out as part of the final recording?
Not in the recording. No, we cannot do that. Sorry.
Okay, if the attendee wants to drop his email address in the chat, I can send it to him. Otherwise, I guess that's the only way, right?
Oh, we've got another question coming in. Is there licensing for vGPU as part of vMug Advantage? And
I don't think so.
vMug Advantage is only VMware products, right?
I believe.
Yes, I'd be pretty certain there isn't.
Yeah. All right. I'm just going to be accepting any last questions before I end it. So, oh, here we go. What is the next NVIDIA GPU to upgrade from T4?
So we're still working on the future product. I don't think we're at the stage to review the roadmap, but stay tuned. You'll hear back from us in a few months, I guess.
All right, and with that, it looks like we're going to be ending. So, thank you so much, Ben, Manvender, and John, for taking the receive a follow-up email with the on-demand link from today's webcast. To find out more about the vMug webcast program, visit vmug.com and check out the education page. Please make sure to complete the short online evaluation that will pop up as you exit the webcast and let us know how today's session went. And from all of us here at vMug, thank you and have a great rest of your day.